Okay, so today I will show you how to draw the Lewis structure for ICl3. We have I in the 7th group, which would mean it has 7 valence electrons. We have 3 Cl, which is also in the 7th group. So 3 times 7 is 21. We add those up, it's 28. So now let's draw the Lewis structure. You have I, a Cl on each side. And if we count each of these bonds, which is worth 2 valence electrons each, that means we subtract 6. So we are left with 22. And if we add 2, we add 6 valence electrons to each Cl, we still have 18. I mean, we'd subtract 18 and we'd have 4 left. And those 4 are going to go up here with the I. The first part of the question asks for the specific geometry. And we have 3 bondings and 2 lone pairs. This would mean that it's a T-shaped geometry. It has a T-shaped geometry. As you can see, it looks like a T. The B part is asking if it's a polar or non-polar. It is polar because, as you can see, the 3 Cl's will have more force and will be pulling against the 2 lone pairs, even with much more strength than they would. So it is pulling to one side of the structure. Now for the C part, it's asking for the overall electron arrangement. It has, so let's go back to part A. So it has 3 bonding, and 2 lone pairs. We add those up, which equals 5. And every structure that has 5, that adds up to 5, makes it a trigonal by pyramidal. Now, for part D, it's asking for the hybridization. Sorry. So it has 3 bondings again and 2 lone pairs. 1 plus 3 plus 1 equals 5. If we check our chart, it's going to be sp3d hybrid orbitals. And now we are going to show why that is. So we will draw the orbital diagram for this specific atom. So we have I, which is in group 7A, and on this side of the periodic table, it's down 5. So that would mean that it would be 5s2 5p5 for the valence electron configuration. And for each one of these, you would have, so for each orbital, so S has 1 and P has 3. So we fill them in. So there's 2. So we're going to put an up arrow and a down arrow. And we have 5P, 5. And we have the 3. So we're to do 1, 2, 3, 4, and then 5. And we have to show the bonding, which would be 1 lone pair, and the 3 bonding, and 2 lone bonding, which would be a pair. So obviously this is not going to work. So we go back to our hybrid orbitals and we see that there's a D. So it means we're going to have to put in the 5D, which has 5 orbitals. And all we have to do is give 1 arrow to one of the Ds. So the final result is S, lone pair, P, 3, 1, 2, 3, 4, sorry, because we gave that away already, and D. As you can see, there's 3 bonding and 2 lone pair. That's about it. Thank you.